plus 1 factorial by n plus 1 power n plus 1 and a whole square. Okay. Now, the ratio un upon un plus 1 is equal to, so first thing, n factorial by n power n whole square, nothing but n power 2n one can write, and by un plus 1 means in un plus 1 the denominator goes to numerator, this one whole square, by n plus 1 factorial, Now write the similar terms together, that means n factorial and n plus 1 factorial together, and n plus 1 whole to the power of n plus 1 this whole square by n power n whole square, Now here n factorial, this n plus 1 factorial can be taken as n factorial into n plus 1, and here also one can write, this is one more step I will write, this is 2 of n plus 1, 2 of n plus 1 or 2n plus 2 one can write. This is what? 2n plus 2, and this is n to the power of 2n, Now this term gets cancelled, n factorial, and this is 1 by n plus 1, and coming to here, take n common, outside it becomes n to the power of 2n plus 2, and what is this? 1 by 1 plus 1 by n whole to the power of 2n plus 2, whole by n to the power of 2n, Now this is equal to, here you take n common again, this is 1 plus 1 by n, and here n power 2n gets cancelled, and remaining term is n square will be there, and I will write 1 plus 1 by n whole power 2n into 1 plus 1 by n whole square, right? Okay. Now 1 plus 1 by n gets cancelled, and 1 n gets cancelled. So what is un by un plus 1? Un by un plus 1 is equal to 1 n gets cancelled, so there will be 1 n here, and next 1 plus 1 by n gets cancelled, so there will be 1 plus 1 by n term, and one more term is 1 plus 1 by n whole to the power of n this whole square. Any more? Right. Therefore now apply the limit value, this is limit un over un plus 1 as n tends to infinity is equal to limit n tends to infinity, this is n 1 plus 1 by n, and this is 1 plus 1 by n power n whole square. Why I am writing like this 1 plus 1 by whole power n? Because this goes to infinity, this is 1 plus 0, and this goes to e. Okay, so answer is what? Infinity. Infinity means what? Infinity value in ratio test. What is the rule? Find limit un by un plus 1. If it is L greater than 1 converge, L less than 1 diverge, and L equal to 1 test fails. Now infinity means what? Its value greater than 1. Therefore by using ratio test, sigma un is, what is this? Convergent. By using ratio test, sigma un is convergent. This is one problem. Okay, and the next one is, and the next problem is test the convergence of the series. I'm not writing always test the convergence, just write this 1 plus 2 factorial by 2 square, 3 factorial by 3 square, not 3 square, 3 cube, plus 4 factorial by 4 to the power of 4, and so on, Okay, now solution. What is the nth term of the series? Nth term is, what is the nth term of the series?
n factorial by n power n.
That means this 1 can be written as 1 factorial by 1 power 1. So this is n factorial by n power n. N factorial by n power n. No need to delete any term, right? Okay, n factorial by n power n. Now factorial term is there, so apply ratio test. Un plus 1 you find, that says n plus 1 factorial by n plus 1 whole to the power of n plus 1. Now take the ratio un upon un plus 1 is equal to, this is n factorial by n to the power of n, and when un plus 1 is there, then denominator becomes numerator by factorial. And writing the similar terms together, n factorial by n plus 1 factorial, and n plus 1 whole to the power of n plus 1 by n to the power of n. Since limit is tending to infinity, take n common in every term, and here this is n factorial by, I can write this as n factorial into n plus 1, and take n common outside, it becomes n to the power of n plus 1, and this is 1 plus 1 by n whole power n plus 1 whole by n power n. And which terms are cancelled? This one, and n power n gets cancelled. So the remaining terms are 1 by n plus 1, and 1 n will be there here, and I can write 1 plus 1 by n whole power n and 1 plus 1 by n. So this term also, sorry, not this. Next step is, again take n common in denominator. This is n common, 1 plus 1 by n into n, 1 plus 1 by n whole power n into 1 plus 1 by n. Now this 1 plus 1 by n cancelled, this n gets cancelled. So what is the last term? Un over un plus 1 is equal to, what is the this term? This. Now apply limit value. Limit of un upon un plus 1 as n tends to infinity is equal to limit n tends to infinity 1 plus 1 by n whole power n. That is nothing but e. E value means 3 point something now. So it is greater than 1. Greater than 1. Therefore, by ratio test, sigma un is convergent series. Okay, these are the problems based on factorial terms. Now let us see some more different problem. Yeah, take this, test the convergence of the series sigma n equal to 1 to infinity n factorial into 3 power n by n power n by n power n. Solution. The nth term is clearly it is given, n factorial by 3 to the power of n by n power n. And n plus 1th term is n plus 1 factorial 3 to the power of n plus 1 by n plus 1 power n plus 1. N plus 1 power n plus 1. Now un by un plus 1 is equal to n factorial 3 to the power of n by n to the power of n into n plus 1 whole power n plus 1 by n plus 1 factorial 3 to the power of n plus 1. Now writing the similar terms, that means factorial terms together, and 3 power n by 3 power n plus 1 term together, and these n powers together, n plus 1 whole power n plus 1 by n power n. Now take n common everywhere. This is n factorial by n factorial into n plus 1, and here you will get definitely 1 by 3, and here n power n plus 1 common, so 1 plus 1 by n whole power n plus 1 by n power n will be there. So which terms gets cancelled? 1 n power n gets cancelled, n factorial gets cancelled, and the next one, in the denominator you take n common. This is n common, 1 plus 1 by n into 1 by 3, and I can write this 1 plus 1 by n whole power n, 1 plus 1 by n. Now this 1 plus 1 by n gets cancelled. N is there now. Wait, here one n term will be there, here one n term will be there, so that n also gets cancelled. So what is the final un expression for un by un plus 1? 1 by 3, 1 plus 1 by n whole power n. Okay, now apply limit un over un plus 1 as n tends to infinity. 1 by 3 is the constant, 1 plus 1 by n whole to the power of n. So what is this value? E by 3. E by 3 means what? Definitely less than 1. E by 3 value, L value less than 1. Therefore, by ratio test, sigma un is divergent. By ratio test, sigma un is divergent. Okay, this is one model problem. And in terms of x, let us consider one problem. Yeah, take this. Test the convergence. Test the convergence of the series x by 1 plus x, x square by 1 plus x square, x cube by 1 plus x cube, and so on, and so on. So what is the solution? What is the nth term? Obviously, this is x to the power of n by 1 plus x to the power of n. Okay, so what is the n plus 1th term? X to the power of n plus 1 by 1 plus x to the power of n plus 1. 1 plus x to the power of n plus 1. So what is the ratio? Un by un plus 1 equal to un by un plus 1 equal to x to the power of n by 1 plus x to the power of n, and yeah, what is this? Denominator becomes numerator here. 1 plus x to the power of n plus 1 by x to the power of n plus 1. X to the power of n plus 1. So what is this? X to write similar terms together. This into 1 plus x to the power of n plus 1 by 1 plus x to the power of n. 1 plus x to the power of n. So what is this finally? This is equal to 1 x power n gets cancelled, and this is 1 plus x to the power of n plus 1 by x into 1 plus x to the power of n. X into 1 plus x to the power of n. So what is this is? This is equal to un by un plus 1 equal to 1 plus x to the power of n plus 1 by x plus x to the power of n plus 1. X plus x to the power of n plus 1. Okay, and what is the value of this integral when I take limit? Limit un by un plus 1 as n tends to infinity. As n tends to infinity. I can write directly without this. Let us use this. 1 by x, 1 plus x to the power of n plus 1 by 1 plus x to the power of n. 1 plus x to the power of n. Then how you can write what is the limit value as n tends to infinity? As n tends to infinity, x to the power of n tends to 0 when it is possible, when x is less than 1, isn't it? When x is less than 1. Okay, so there are cases here when x less than 1, greater than 1, like that. Okay, so let me write one by one. First case, let me write here. Okay, put like this. When x less than 1, then x to the power of n tends to 0 as n tends to infinity. You know this, as n tends to infinity. Therefore, limit n tends to infinity un by un plus 1 equal to what? This is limit n tends to infinity. This 1 by x outside, there is no n terms here. 1 plus x to the power of n plus 1 by 1 plus x to the power of n. So this is 1 by x. 1 plus 0 by 1 plus 0. So this value is what? Finally 1 by x. This is the value of L. This is the value of L, and what is my x value? X is greater than 0. 1 by x if x is less than 1. if x is less than 1. And this 1 by x means what? Now here I can write this when x is less than 1. No? So 1 by x becomes what? Since x is less than 1, 1 by x is greater than 1. 1 by x is greater than 1. Okay, therefore limit un by un plus 1 is equal to 1 by x. What is this value? Greater than 1. I can make conclusions. Okay, first one anyway. Case 1 is what? X less than 1. Greater than 1. This implies sigma un is greater than 1 means what? Convergent. Sigma un is convergent by ratio test. By ratio test. Okay, this is 1. Now, when x greater than 1, second case, when x greater than 1, then x to the power of n tends to infinity as n tends to infinity. Obviously, this is true. X is greater than 1 means what? X power n, when n raises, then x power n goes to infinity. Then, what is the limit value? Un by un plus 1 as n tends to infinity. What is this? 1 by x, limit n tends to infinity, 1 plus, what is the expression? Yeah, x to the power of by 1 plus x to the power of. So what is this value? T, 1 plus infinity, isn't it? By 1 plus infinity. So what is this value? Infinity by infinity structure. This is, what is this? Infinity by infinity structure. Then how you solve this problem? Anybody? L'Hospital rule means what?
Sir, you can take common.
Sir, by taking x power n common.
What is that common C?
Yes, sir.
Yeah.
In numerator and denominator, x power n plus n in x power.
What is the common? X power? I will take x power n. Okay, x power n plus 1 in numerator. So 1 plus 1 by x power n plus 1 by x power n common. 1 plus 1 by x power n, correct? Okay. Now what is this value? This is 1 by x. X power n gets cancelled. Correct? And 1 by x, limit n tends to infinity. There will be 1x here. There will be 1x here. And what is this? 1 plus 1 by x power n plus 1 by 1 plus 1 by x power n. Now, since x value is greater than 1, 1 by x is less than 1. 1 by x is less than 1. That implies as n tends to infinity, 1 by x power n tends to what? Since this value less than 1 goes to 0. So using that, this x gets cancelled, and what is the remaining value? 1 plus 0 by 1 plus 0. This value is 1. This value is 1. That is which value? Limit un by un plus 1 as n tends to infinity. This is the value is 1. Since L equal to 1, ratio test fails. L equal to 1, ratio test fails. This is the case for what? This is the case for when x greater than 1. When x greater than 1. Now, when x equal to 1, last step, third case. What is the third case? When x equal to 1. What happens when x equal to 1? I already told you. Begin with again nth term. So what is actually nth term is here? X un equal to, what is the nth term? X to the power of n by 1 plus x to the power of n, or sigma un. Let me consider series. Okay, that means what? This is x power 1 by 1 plus x power this x by x square, right? And so on. When x equal to 1, what is the series becomes? Sigma un becomes what? Sigma un becomes what? 1 by 2. This is also 1 by 2 plus 1 by 2 and so on. And so on. Now, how to decide the convergence, divergence, and one more point. Here, therefore, what is the nth term here? Simply 1 by 2. Agreed? Nth term is 1 by 2. Any doubts? If still any doubt, we have what is un equal to x to the power of n by 1 plus x power n. At x equal to 1, what is un is nothing but 1 by 2. Un is 1 by 2. Okay. Now tell me how to check the convergence divergence. One can say our standard rule. Take the sum of the first n terms. Take the sum of the first n terms. 1 by 2 plus 1 by 2 plus 1 by 2 up to 1 by 2. Sn equal to. So that value becomes n by 2. And apply limit. Limit of Sn is limit n tends to infinity n by 2. That goes to infinity. That means sequence Sn is divergent. So series also divergent. That is one way of proof. Another way is, what is this nth term? The nth term is what? The nth term is un equal to 1 by 2. Now, the logic is here. Take directly n tends to infinity. Limit n tends to infinity 1 by 2. What is this value? 1 by 2, which is not equal to 0. Where I told you one theorem. What is that? Since sigma un is positive term series and
Divergent.
limit un n tends to infinity not equal to 0. Do you remember? Okay.
Yes, sir.
Limit
Divergent.
un not equal to 0 and a positive term series, then sigma un is what series? Definitely it is divergent series. Sigma un is divergent series. Therefore, here sigma un is divergent. Divergent for what case? For x equal to 1. So finally, write the conclusion. What is the conclusion? Final conclusion. Sigma un is convergent. When it convergent, if what is the case? X less than 1. And divergent. When divergent is there, yeah, divergent if x equal to 1. Divergent if x equal to 1 and test fails. That means ratio test fails if x greater than 1. Okay, this is the model. Any doubts? Once again, the problem is x to the power of n by nth term. This is the problem, and writing the nth term and n plus 1th term, taking the ratio un upon un plus 1. Finally, I'm getting this expression 1 plus x power n plus 1 by x into this. So since this terms, the un by un plus 1 term contains x and the n terms, when I take, I have to consider 3 cases: when x less than 1, when x greater than 1, and when x equal to 1, because it depends on x. So I have considered one thing, case 1. Case 1 is what? When x less than 1. When x less than 1, x power n tends to 0 as n tends goes to infinity. So I have calculated limit value. I got 1 by x. L value. Since x less than 1, 1 by x is greater than 1. 1 by x limit value greater than 1 means the series is convergent. Convergent for what? For x less than 1. Okay. Next one. When x is greater than 1, what happens? X power n goes to infinity as n tends to infinity. I have considered the limit of the ratio. Then what I am getting? The limit of a ratio as 1. When ratio test limit is 1, the test fails. Therefore, when x is greater than 1, ratio test fails. And when x equal to 1, the nth term becomes just 1 by 2. And since it is a positive term series and limit value is not equal to 0, according to theorem, the series is divergent. And finally, these are the conclusions. Okay. Next
Sir,
problem.
if ratio test, sir,
Ah,
small doubt. Sir,
yeah.
if ratio test fails, we have to do in another method to test convergence or divergence. Sir, in exam, for suppose
Yeah, good doubt. See, always remember, here ratio test fails for what value of x?
it's greater than 1.
X greater than 1. And remember, the Point is, when x equal to 1, the test fails, then only we can apply another theorem, another test. But when x greater than 1 means, what is the value of x? Greater than 1 means it is random. You can take 2, 3, whatever it is. Using this x greater than 1, I cannot decide this limit value. Already I decided. When x greater than 1, I am getting what is this value? L value as 1. Right? And remember, when test fails means when x equal to 1, the test fails, then you can go further test. You can go for further test. Only this case is possible.
Okay, sir.
Okay. Okay. Right. Next one. Next problem. Let me take. Yeah. Sigma root n over root of n square plus 1 into x power n. Into x power n. N tends to n equal to 1 to infinity. Now see this. What is the nth term here? Root n by root of n square plus 1 into x power n. And what is the n plus 1th term? Root over n plus 1 by root over n plus 1 square plus 1 x power n plus 1. Right, clearly here n is replaced by n plus 1. Now the ratio un over un plus 1 is root n by root over n plus 1 x to the power of n into this one, root of what? N plus 1 whole square plus 1 by root n plus 1. And where is this becomes 1 by, yeah, this will be in denominator only, 1 by x power n plus 1. So let me write similar terms together. First these two. Next x power n by x power n plus 1. Next one under root of n plus 1 whole square plus 1 by root of n square plus 1. Now take n commons. This is equal to root n, and take n common, outside it becomes root n, 1 plus 1 by n, and here you will get 1 by x, and here also here n common, n square, then outside the root it becomes n. So root of 1 plus 1 by n whole square plus, here you will get 1 by n square, and here also n square common, outside n, root 1 plus 1 by n square. So what are the terms getting cancelled? This one, this one. Right. Next, so this is un by un plus 1 limit value as n tends to infinity. This is equal to limit n tends to infinity. 1 by x will be there, 1 plus 1 by n is there, and here root of 1 plus 1 by n square plus 1 by n square by 1 plus 1 by n square. So finally this value 0, this value 0, this value 0, this value 0. So this is totally 1 by x will be there. This is the value of limit L. Okay, therefore by using ratio test, sigma un is convergent if L is greater than 1. That means 1 by x greater than 1. That means x less than 1. And sigma un is divergent if L is less than 1. That is 1 by x less than 1. Means x greater than 1. And test fails. Ratio test fails. Ratio test fails if L equal to 1. If L equal to 1. That is 1 by x equal to 1. That implies x equal to 1. X equal to 1. Okay. So I have two conclusions. Convergent if x less than 1. Divergent if x greater than 1. And the test fails if x equal to 1. Now let me consider when x equal to 1. When x equal to 1, what is the nth term becomes? When x equal to 1, what is the nth term here? Root n by root n square plus 1 x power 1. X is 1 means This is root n by root of n square plus 1. So since there is no x powers factorials, I can apply limit comparison test. 1 plus 1 by n square. Is it correct? Right. This implies un equal to what? 1 by 1 by root n into 1 plus 1 by n square. Okay. Choose Vn equal to 1 by root n. That implies sigma Vn equal to sigma 1 by n power half, n power 1 by 2. Power 1 by 2 means 1 by 2 is less than 1. So this series is what? Divergent series. Now limit un over Vn as n tends to infinity. Un over Vn as n tends to infinity, 1 by root n, 1 by root n gets cancelled. This is limit n tends to infinity 1 by 1 plus 1 by n. So this value is 1 by 1 plus 0 under root. So this value 1.
1 by root 1 plus 1 by n square.
Yeah. Right. This is 1 not equal to 0 and finite. Not equal to 0 and finite. Therefore, by limit comparison test, since sigma Vn is divergent, sigma un also divergent. Sigma un also divergent. Finally, conclusion. What is the final conclusion? Sigma un is convergent and is divergent if x convergent for what I get? Convergent for x less than 1. Convergent if x less than 1 and divergent when x greater than or equal to 1. X greater than or equal to 1. This is one model. And let me write another one. Next problem that you can do. Yes, you can do. Yeah, take this. Sigma n equal to 1 to infinity. 3, 6, 9 and so on 3n by 4, 7, 10 and so on 3n plus 1 into 5 power n by 3n plus 2. 5 power n by 3n plus 2. Solution. So this is summation of what? This entire is nth term, sigma un. Therefore, what is the nth term here? Nth term is un equal to 3 into 6 into 9 into 3n by 4 into 7 into 10 into 3n plus 1 into 5 to the power of n by 3n plus 2. 5 to the power of n by 3n plus 2. Now, see, even though the series is not containing factorials, not increasing powers of x, it is not possible to solve by using limit comparison test. And see, this is what is the structure. It is the product of some terms, product of some finite number of terms. In such cases also, you have to apply a ratio test. You have to apply a ratio test because this is 3 into 6 into 9. How many terms? 3n. Okay, some product of some finite number of terms. Then whenever some product of some finite number of terms are there, apply ratio test. Then what is un plus 1 here? 3 into 6 into 9. This becomes 3 of n plus 1 by 4 into 7 into 10 of 3 of n plus 1 plus 1 into 5 power n by 3n plus 2. Sorry, 5 power n plus 1 by 3n plus 1. 3n plus 1 plus 2. So what is this? Un plus 1 is now un plus 1 equal to 3, 6, 9. This is 3n plus 3 by 4, 7, 10. This becomes what? 3n plus 3 plus 4 plus 4. 5 to the power of n plus 1 by, this is 3n plus 5. 3n plus 5. Now un by un plus 1. Un by un plus 1. This is 3, 6, 9 into 3n by 4, 7, 10 up to 3n plus 1 into 5 to the power of n by 3n plus 1, 3n plus 2 multiplied by un plus 1. So this 4, 7, 10, 3n plus 4 comes to the numerator by 3, 6, 9 will be in denominator, 3n plus 3, right? And this 5 power by means you will get 3n plus 5 here by 5 to the power of n plus 1 here. So writing similar terms together, 3, 6, 9, 3n by 3, 6, 9, what is this term? 3n plus 3. And can you, anyone tell what is its before term?
3n, sir.
3n, exactly, 3n. Now, multiplied by this 4, 7, 10, and so on, 3n plus 4 by this one, 4, 7, 10, 3n plus 1. I will write one more here. This is 3n plus 1 and 3n plus 4. 3n plus 1, 4 before term is 3n plus 1 multiplied by 5 to the power of n by 5 power n plus 1 and 3n plus 5 by 3n plus 2. 3n plus 5 by 3n plus 2. And next one, this is now which terms getting cancelled? Up to 3n gets cancelled. Up to 3n, this one gets cancelled. So 5 power n gets cancelled. So 1 over 5 will be there. And here you take n common, 3 plus 5 by n. And here you take n common, 3 plus 2 by n. So the limit value now, un by un plus 1 as n tends to infinity is equal to this n gets cancelled, 1 over 5 limit n tends to infinity, 3 plus 5 by n by 3 plus 2 by n. So this value is what? 1 by 5. This is 3 plus 0 by 3 plus 0. This is 1
Sir,
by 5. 1 by 5,
sir,
yeah.
3n
Yeah,
plus
yeah.
4 by 3n plus 3 is remaining now, sir.
Where?
In the tag.
Right. Yeah, wait. So what is this value? What are this? Yeah, this term will be there. This is 1 by 5 and 3n plus 4 will be there. Here 3n plus 3 will be there, right? In denominator. Right? This term, right? And here 3n plus 5 will be there and 3n plus 2. So 1 by 5. Take n common. So n square gets cancelled. The remaining terms are 3 plus 4 by n, 3 plus 3 by n, 3 plus 5 by n, and 3 plus 2 by n. 3 plus 2 by n, correct? Now if I apply limit, what I'm getting, this is if I apply limit 3 plus 0, 3 plus 0, 3 plus 0, 3 plus 0. So anyway, the value is what? 1 by 5. 1 by 5 is less than 1. 1 by 5 is less than 1. Therefore, by ratio test, sigma un is what? Divergent. Sigma un is divergent. Now, you take some problems based on ratio test assignment. First one, 1 plus 1 square 2 square by, all of you remember the properties of series. You can delete some finite number of terms also in a series. 1 square 2 square 3 square by 1 3 5 7 9 and so on. Second problem, 4 by 18, 4 into 12 by 18 into 27, 4 into 12 into 20 by 18 into 27 into 36 and so on. Third problem. 1 by 1 power p. 1 by 1 power p. X by, yeah, someone mute your audio. X square by 5 power p and so on. Nth term is given here. X to the power of n minus 1 by 2n minus 1 power p and so on. And next fourth problem. 1 plus alpha by 1 plus beta. 1 plus alpha, 1 plus 2 alpha, 1 plus beta, 1 plus 2 beta, 1 plus alpha, 1 plus 2 alpha, 1 plus 3 alpha by 1 plus beta, 1 plus 2 beta, 1 plus 3 beta and so on. Next fifth one. Sigma n cube minus n plus 1 by n factorial. Sixth one, always n is from 1 to infinity if it is not mentioned. Next problem. Under root 1 by 2 plus root over 2 by 3 into x square. X square is outside the root. Root over 3 by 4 into x cube and so on. Next, seventh one. 1 by 3 whole square. 1 by 1 into 2, 3 into 5 whole square. 1 into 2 into 3 by 3, 5, 7 whole square and so on. Next one. Yeah. 1 plus 2 power p by 2 factorial plus 3 power p by 3 factorial, 4 power p by 4 factorial and so on. And so on. Another one. Yeah, these are over. Yeah, last. Ninth problem. 1 plus 2 by 5 into x plus 6 by 9 into x square, 14 by 17 into x cube and so on. Nth term is given here. No need to find. 2 power n minus 2 by 2 power n plus 1 x to the power of n minus 1 and so on. Here x greater than 0. X greater than 0. These are the 9 assignment problems based on ratio test. Okay, solve it. Now, any doubts?
Excuse me, sir.
Yeah. Done.
Sir, in yesterday's homework problem, I have one doubt, sir. Sigma 1 by n power
Which
p,
one?
how can... Sigma
Yeah,
1 by
sigma.
n power 1 by n power p.
What do you
In
need?
that, how can we solve for p is equal to 1, sir?
Yeah, simple, no? Yeah, see. I think you got, what is this one? P greater than 1, converge.
Converge.
P less than 1, diverge. You got it now?
Yes, sir.
Yeah, P equal to 1 you need, right?
Yes, sir.
When P equal to 1, what is sigma? Un is what?
1 by 1 by.
Un is what?
1 by n.
1 by n, right? Right? 1 by n. This implies what is f of n? F of n is nothing but un, isn't it?
Yes, sir.
Integral test.
Yes,
Right?
sir.
This implies what is f of x? 1 by x.
1 by x.
Is decreasing function. Is decreasing function, agreed?
Yes, sir.
Right? And
Yes.
what is this integral test? 1 to infinity f of x dx. 1 to infinity 1 over x dx. This is log x from 1 to infinity. Infinity, log 1. That is value
Infinity.
Infinity.
Okay.
That means 1 to infinity f of x dx, what? Since it is infinite value, diverges.
Divergence.
Correct?
Yes.
Therefore, by integral test. Therefore, by IT means integral test, sigma un also diverges. And remember, for p greater than 1, p less than 1 also, you have to do in integral test only. This entire proof of sigma 1 by n power p by using integral test.
Yes.
Clear? Yeah.
Yes, sir. Thank you.
Any more doubts?
Sir, in exam, to say the function is decreasing, we have to differentiate the function, sir.
Yeah, no need. See, 1 by x square, all those functions are decreasing, no? It's obvious. No need.
Okay, sir. Okay, sir. Thank you, sir.
Any more? Now, all are present. CR Sanjana. One candidate is absent. Who is that? Three candidates. 55. 3 candidates are absent.
Sir, I will check it out, sir. I'll send the Google form to you.
Okay, right. Any more doubts?
Sir,
All of
what's
you,
the
please maintain notes.
Sir, I have
Tell
a doubt.
Sanjana.
What is the portion
Yeah.
for next class test, sir, which we have on Jan 27th to 30th, as per the almanac?
As per the almanac, whatever the syllabus is covered up to that before day. Not before day, 5 days before. Okay?
Okay, sir.
Mostly, I think this unit will complete sequence and series, and we will start calculus also, differential calculus. Okay, within 5 hours, for now, 4 to 5 hours, this unit will complete. Anyway, easy chapter, this one, sequence and series. It's a scoring one. Be thorough with this. Please maintain notes. Okay. నేను ఆల్రెడీ నేను ఇస్తున్నాను పీడిఎఫ్ అని చెప్పి మీరు అదే ప్రింట్ తీసుకొని అదే నోట్స్ అనుకోకండి. ప్లీజ్ వర్కౌట్ ది ప్రాబ్లమ్స్. ఓకే. Any more? Shall I stop? Yeah, Kashmiri students, Kalpana Rai, You are there? Kalpana Rai.
Yes, sir.
Are you getting everything? Sequence and series chapter? Any doubts?
No, sir.
Okay. If you have any doubts, just WhatsApp me. Right. Okay. I will stop the class. Thank you.